the team is back with another episode of Topical Explainers for the second chapter of CAIE AS Level Pure 1 Maths. In this video, we will be discussing about functions, and to simplify the topic and provide us with all the information needed, we have Pratyush here with us.
Hey guys, let's head over to the presentation now. Today we're going to be covering mappings, domain, range, composite functions, inverse functions, and the three transformations of functions. So let's get started. Before we dive into this chapter, you should already have some ideas about maths. First, you should be able to substitute values into equations, such as x equal plus 5, and you substitute in 5. That's pretty basic arithmetic. And you should be able to sketch the graphs of an equation. This includes quadratic curves from the previous chapter. And you should have a basic belonging of the concept of sets, such as x belongs to, let's say, real numbers. You should understand what that means. And you should already have completed the previous quadratics chapter, because topics such as completing the square, vertex of curve, will be used in this chapter. So let's get on with it. First, we're going to look at mappings, domain, and range. A mapping simply describes the relationship between two sets of numbers. What that means is, if we have an input set of integers, which is 1, 2, 3, 4, and then we have an output set, which we get by doubling it, then this effectively is a mapping. We can write the mapping as f of x equals 2x. And this gives us the relationship between the input set and the output set. F of x is 2x. Basically, you take the input set and you double it to get the output set. The x values, or the input, are called the domain. The fx values are the output, and they're called the range. And 2x is the mapping, or the relationship between the two. So to recap, an input and an output, you have an input and an output, and the relationship between the two is called the mapping. Okay, let's carry on. Now, a function is a specific type of mapping. Not all mappings are functions, but all functions are mappings. So let's say you have, where's my pen gone? 1 second, found it. Let's say these are mappings, the whole thing, and a certain portion of them are functions, but not. And a function is a specific type of mapping where one input has one output only, i.e., one domain element maps onto one range element. There's different types of functions. This one's called a one-to-one mapping because, as you can see, each input maps exactly onto one output. This is a function, yes, because it follows the rule. A many-to-one mapping might seem confusing at first, but if you see, each input here has only one output. There's only one line going from the input to the output. So since there's one output for one input, even though two inputs can have the same output, this is still a function. So a many-to-one mapping is a function. However, a one-to-many mapping is not a function. This is because the rule says that each input has to map onto one output, but here, one input maps onto two outputs, such as in this square root, because of the plus minus. So this is not a function. This comes in handy later, so keep this one types of mapping in mind. And when you have a function, you can restrict the input values, or the domain, and this will affect the possible range of the outputs. So let's look at this question here. We're given the mapping, or the function, now we can call it. The function f of x is equal to 3x minus 1. That's the rule. And this, so that's the map. And this little thing after the comma, x is equal to or greater than 2, is it gives us the possible values for the domain. So it's the domain, it tells us the domain. So if we want to find the possible range, we basically plug in the 2 into this function. So we put 3 times 2 minus 1, which gives us 5. And this means that at this value, it's 5. And x is greater than or equal to. So our f of x values will, wait, no, not f of 5, my bad. F of x will be greater than or equal to 5. Why is this? Because, well, the least value we can input into this equation is 2. And let's just look at the graph to see what that means. These are the x values. These are the y values, remember, x, y. And the minimum value we can input, so x has to be greater than, x is greater than or equal to 2. So only these x values are input. And since those x values are input, only these y values can be output, because that's what's according to the rule. So for 2, we get 5. And since you can only input greater than 2, and inputting a bigger number makes it go higher, then you get greater than or equal to 5. And make sure to match the greater than or equals to or the greater than. So be careful with inequalities, is what I'm saying. Because if it was minus 3x, then it'd be the opposite. Okay, so now let's look at the next one. This is f of x is equal to 3 times bracket x minus 3 squared minus 6. And, well, x is real. That just means it's not imaginary, and what x is real, it means it's anywhere on the xy plane. So you don't need to worry about that very much. But what it means, from the last chapter, we learned that you can find the vertex of a quadratic. This is completed square form, and we know that we can find the vertex of that curve. So x is positive, so it's a smiley face. We know that. And the minimum point is going to be, see, x here is inside bracket with minus 3. So if you put x equal to 3, then this cancels to 0. And that's the lowest point possible. And if x equals to 3, so the xy would be 3, and that leaves the outside value to be minus 6. So that's the coordinate of the lowest point on the graph. So the range are the y values as we've seen, with the input being the x values. So what that looks like on the graph, I'm going to clear this real quick. This is f of x on the graph here. What that looks like is, here's our vertex, 3, minus 6. And the minimum x, see the values of x that we can get from this are all greater than minus 6. There's nothing less than minus 6. Since that's the minimum point, everything on this curve will be above minus 6. So we know that f of x, that's a wonky x, but okay. F of x is greater than or equal to. In quadratics, always or equal to, because that point on the bottom of the curve is equal, minus 6. So that's our range of f of x. Oh, kind of cross that. Okay, now let's look at this last one here. G of x is equal to, see, functions, they can have different letters. You don't have to have f. That'll come in handy later. It's 2x squared. And the values of x input are between minus 3 and 1 inclusive. What that means is it's within that values of x. And for those values of x, what's the possible values of y? Well, if you graph it, then it looks like this. So you might be tempted to think the lowest point is here, just because, biggest number must be 1, so the highest point must be here. No, that's not true. You should know that quadratic can dip below as well. So what happens here is it dips down to 0, and it goes up to 18. How do we math this? Well, you should know that for 2x squared, that's basically already completed square form. You can put, I don't know, you can put something to make it look nicer. And so hence the lowest point is going to be 0. So you should know that should be one bound of your range for your y values. And the highest point is going to be the highest number. And in highest magnitude number, so the sign doesn't really matter. So minus 3 squared times 2 is going to give you 18, because that's 9 times 2. And that's going to give you 18 up here. So you know that the range of the function here is f of x. That's not f. This is g of x, remember, write it correctly. G of x is greater than or equal to 0, but it's less than or equal to 18. So this is that range. Okay. And similarly, like we just restricted range, we can also restrict domain. And this can be a little more confusing, but we'll look at something in the future that'll help us with this. So here's this question. F of x is 5 over x minus 2 whole square. X belongs to real numbers. And we're given a restriction for domain. I mean, we're given a restriction for range, because f of x. And we need to find the domain. So we need to find what is x's values, possible values. So what we're going to do is we're going to make f of x, we're going to make x into the subject. X minus 2 squared. We're going to make x into the subject, and then we're going to put in the little range. So, or we could just make equal to 5. Okay, look. So we have f of x is equal to or greater than 5. Let's treat it just as 5 for the moment. So let's say 5 equals to all that. And we can rearrange this now to make, first you're gonna, I'm just gonna take a shortcut, it's algebra. So x minus 2 whole square over 5 equals 5. Then we multiply by 5. You can get 5 over, you can just swap this around, equals x minus 2 whole square. And this becomes 1. So 1 is equal to x minus 2 whole square. So plus minus 1 is equal to x minus 2. So let's just bring that up here. 2 plus minus 1 is equal to x. So that's just two possible values. We need to now make it into an inequality. And remember from the quadratics chapter, what we did is we drew the graph, which might be a bit confusing here, but if you've studied some background mathematics, then you should know about the shape of a 1 over x squared graph. Looks something not like that. It looks more like, I'll just show you guys here. It looks like that. And this keeps going up to infinity. There's never reaches here. This is what it looks like. So our values of 2 plus minus 1 are shown here as 2 minus 1 is 1 and 2 plus 1 is 3. And that gives you the values which cap at 5. As you can see, as the range is 5, above 5, so we want the values which are greater than 5. So that's actually this range here. No, wait, sorry. The words range are quite general and domain, so you can get confused, so don't get confused with that. This is a domain. The values of x are from 1 to 1 between x to 3. Remember, we got 2 plus minus 1 equals x. So we get those equal values where they equal 5, and we basically get the range, the domain, the area where they make the equation true, where it's greater than 5, where this curve is above 5 on the y-axis. Okay, so that's all about range and domain. Now let's move on to composite functions. A composite function is when you take the output of a function and input it into another one. Let's say we have these two functions. We have these two functions, f of x and g of x. They're defined as follows. And we can do this notation to show a composite function. What it means is we apply g first and then f. It's basically f of g of x, with the brackets shown neater. What this means is you first do g of x, right? And then you put, instead of, so let's talk a bit about function notation. You see this x here. The thing in the bracket is x, the value of x. And if we put g of x inside the brackets, then we're effectively putting g of x, this bit, as x. And what this becomes is f of g of x, which is 5 minus 2x. Now that looks scary at first, but now you can basically put this value as x into f. So let's take a look at f here. F is 3x plus 2. So to make that happen, we're going to, instead of x, we're going to put this thing in. Oh, that's super not neat. Okay, 3. And instead of x, we're going to put the value of g of x, which is 5 minus 2x. That's all there is to it. So this is now your composite function, f of g of x. But examiners don't like this, so don't write it like this. Make sure to simplify it as much as you can. So open the brackets, make that 15 minus 6x plus 2. So basically you can write minus 6 plus 17. So that's f of g of x. And what that looks like on a graph is this. Wait, no, spoilers. And now let's do the same, but in the reverse order. We're going to apply f first and then g. Remember, you're going to put g and then the value of f of x, which is 3x plus 2. And then we're going to simplify that out. We're going to put in g. So 5 minus 2, 3. The value of x is the value of f, 2. And remember, when you're multiplying by a negative, make sure you keep the sign happening. So 5 minus 6x minus 4. I think that's right, yeah. And this becomes right. And this becomes minus 6x plus 1. See, the two values we got are quite different. This is f of g of x, and this is g of f of x. So the order that you apply these in definitely matters, so be careful of that. We can see this on the graph as, if I just clear this, g of f of x is just down here, while f of g of x all the way up there. They're different lines. Okay, so a little bit more on composite functions. You can do the same function twice, such as here. Question f of x is x squared plus 4. You can find ff of x, which is just, you put in f of x instead of x. So you put x squared plus 4 instead of x. And then you get x. Wait, instead of x, you put x squared plus 4. See, this is x squared plus 4. You see, this term is the x term, squared plus 4. Boom. You're substituting this into x. And you can, of course, obviously you can simplify that out and write that, but it's just to give you an idea here. And you always need to check the domain restrictions when making composite functions, because examiners love to ask you about these. Look at this question here. G of x is x plus 1, but the domain restriction is x has to be less than 4. And f of x is 2x, and x belongs to real. So x belongs to real anywhere on the plane. We don't need to worry. It's not a numerical restriction at this level. So why can f of g of x be formed, but not gf of x? Well, if you take f g of x, you're putting in this here. You're putting in the g, which is already restricted by itself. So it's x plus 1, and you can treat the idea. You don't need to put the restriction in the bracket, but yeah, you probably shouldn't put it. It's just to illustrate the point here. X is less than 4. So this is fine and dandy because g is already restricted, and we're putting in the function, and there's no issue. Everybody's happy. But if we do g f of x, you basically what you're doing is you're putting the values of f, the output of f. You're putting the output of f, which is a range of f of x. You're putting 2x for everything, which actually will, and its range will actually be infinite because it's all the numbers. There's no restrictions on the range, you see? And when you input f of x's range, so f of x's output into gx, this range is the input here, input into g. And g has a restriction that says, hey, you can't have x values greater than 4. But you've just put in the output from fx, which is, hey, it goes up to infinity, doesn't stop. And what that means is f of x's output, or the range of fx, range of f of x is outside domain of g of x. And that's why it can't be formed. It doesn't meet the requirements of this domain restriction because you've put in this range. Savvy? Let's go. Inverse functions. One more thing before we get on to exercises. Don't hold on to your pants. The inverse function maps f of x back onto x, and is written in f to the power minus 1x. This is different from f prime x, so don't get those two confused. And what it means is, let's say you have f of x, which takes x into y, whatever, input and output to out. What operation are you going to do to get it back? That's f minus 1 of x. And as you might have guessed by now, it's literally just the reverse arithmetic operations in the reverse order. So you should know about the order of operations, whatever you say, PEMDAS or BODMAS, brackets, parentheses, exponents, multiplication, division, addition, subtraction. That's the order you typically go things in. Here you go in the reverse order. It's basically just rearranging. So look here. Question f of x is this, and find the reverse. The method is quite simple. Let's say y is f of x, right? Just to make things simpler. And let's swap x and y. That's all. You just put x is equal to 2y plus 3. And now you rearrange for x, which gives you first you subtract over the 3 to the other side, equals 2y. Then you divide the whole thing by 2. So, why does it rearrange for x? Let's make that rearrange for y, my bad. Rearrange for y, and you write x, divide both sides by 2 over 2 equals y. And this, ladies and gentlemen, is your inverse function. So f minus 1 of x is x minus 3 over 2. That's all. And I'll clear that just for now. But take a look here. Since we swapped x and y, the domain and range have been swapped. What that means is it's been reflected in the line y equals x, because that's what we've done, right? We've changed y into x. And if we have something here, it's like change the values of x and y. So y here is x here is y here, vice versa. And that's what the effect has. Some questions will ask this, so be aware that it does this reflection thingy. More on inverse functions. Last thing. To ensure the inverse is actually a function, that means it's not many. It's not one to many. Everything one. No, my bad. Many to one is not a function. What that looks like graphically is here. You see x squared is many to one, because many values of x, let's say 2 values of x, can have the same value of y, right? That's fine. That's a function. But when you do a square root, that's where the problem comes in, because one value of x has 2 values of y. One input has 2 outputs, and that's not a function. So we need to fix this by restricting the domain. Whoa, how did you do that? To positive values. What does that mean? Well, we basically cut this off, because we're only interested in the positive values, and vice versa, that cuts this off, which gives us a nice one line to one line, no x overlaps going on. See, none of that. We've effectively made both things one to one. So when you're inverting, you want to have both of your functions one to one, so that the inverse is also a function and not a many to one. Last thing, some functions are self-inverse. That means the inverse is same as the function itself. Here's a few examples. If you have f of x is 1 over x, let's try to find the inverse of that, shall we? If y equals 1 over x, swap x and y, x equals to 1 over y, and solve for y. What you're going to find is you're going to multiply by y and then divide by x. So xy equals 1, divide by x. Whoa ho ho, would you look at that? You're left with the same thing. So f minus 1 of x is equal to f of x. It's not really a question they really ask, but sometimes the concept does come up. So good to have this knowledge. Here's a graph of that. This is 1 over x. F of x is 1 over x. And let's say f of x is y, because the function is graphed in the y-plane. That's what it means. And you can see that it's perfectly reflected in the plane. See, each x has the same y. Yep. And now, finally, the part you've all been waiting for, the workout. Vyomesh will assist us with this question. And the function here is defined by this. Yes.
Sure. So we could first of all see that the first question 6a is asking us to do it in the completed square form. So to do that, I would first of all take 2 as a factor of 2x squared minus 16. So it would be 2 times x squared minus 8, 8x, brackets closed, plus 23.
Mm-hmm.
Then I would turn the expression inside the parenthesis x squared minus 8x into x minus 4 square, and then minus 16.
Because minus 4 squared. Yep.
Yeah.
Plus 23.
Plus 23. Yeah.
And simplify that, and we're done.
Yeah, that's it.
X minus 4 whole square minus 16. So minus 32 minus 32 plus 23. So basically 2.
That is negative 9.
Minus 9. Epic.
Yeah.
So that's the first question done.
Yeah. And for the second question, when it asks for the range of b, again, we're looking at a completed square form. So it's going to be it's a quadratic equation. So it's going to create a parabola, and we can find the vertex of it. And again, it's a U curve. It's a smiley face. because it has a positive x coefficient. And so the vertex coordinate would be -4 and, well, I mean, +4 and -9. Because if we put x, the value of x as 4, the value of it would be -9, which is the lowest it can go. And so the range of f, simply by looking at the graph, would be, because it's talking about the y-axis, right? If we graph the function of f to y, so that would be f of x is more than equal to -9.
Yep. Yep, it's
Yeah,
greater than because it's above. Yep. Epic. And that's another mark. Now, can you do the last question for us?
sure. So it's asking to find the inverse of the function, right?
Mhm.
So again, it's way better to use the completed square form, especially if they
Definitely.
asked us to do that in 6a. So we would continue with that, but flip the signs of x and y.
Mhm.
So it'll be 2 brackets y minus 4 square minus 9 equals to x. And make that in terms of y. So I would add 9 on both sides.
Wait, -4.
Then divided by 2 on both sides. Then I would root on both sides to remove the square from the left hand side. And then remember the plus minus.
Mhm.
Yeah. And then just add the negative, add +4 on both sides to make it in terms of y. And there we go. That should be the inversive function of the function f. There.
Awesome. Let's check our answers. This is a new feature since last episode. Here we go. And yes, we got this exact form from before. So that's right. 2x. And
Also, there's one thing I did not check. Can you go back to the previous slide? It says
yeah,
that the
we
range,
missed we
yeah,
missed the domain.
yeah, the domain is less than 3. So
So
if we
this is
consider that, then
mhm.
it should only, let's actually see. If the domain is less than 3, then the range, we have to also find the range, what it could be, right? Oh yeah, it's written, we already did that. The range of the
Yeah.
function is more than equal to -9, right?
Hmm.
So so then we have to decide if it is a plus or a minus, because right now we have both plus and minus, right?
Yeah. Wait. Well, can I just clarify this once? Sure.
Sure.
So what happened here is we ignored the domain. So we should have seen that x is greater than no, x is less than 3. So see the whole curve looks like this, but restricted it up till 3, and it doesn't even reach the vertex. So the vertex would be like down here. So this is 3, and this is less than 3. So basically, I don't want to clear this, but I'll just use the next slide. What happens is if we have f of x, f of 3, we're going to put in f of 3 into this equation, completed square. If we put f of 3 into 2x minus 4 squared minus 9, if we put 3 here, then we get 3 minus 4, 2 minus 9. We get 2 minus 9, which is minus 7. And this minus 7 is like here on the parabola, let's say, minus 7. And it's restricted to this part only on this side. So you can ignore that. So this is the lowest that will go. So everything that we have for y is greater than minus 7. And since it's a greater than sign here without the equal to, it's just a greater than, we use the same sign here, greater than. Whereas if it was all the way to
Okay.
the bottom, we'd use equal to, because then it can equal that. Here we do not use that equal to sign. So 1 mark we'd lose, and the correct answer is y is greater than 7. I hope you understand why. Okay, so let's check the third question. That 4 is plus minus that. And in fact, when we're using a function, we have to restrict it to one sign only. I know it sounds counterintuitive because in every quadratic you're like, don't forget the plus minus, don't forget the plus minus. But here in functions, you do want to restrict it so that you don't have a this into this and this is not a function situation. Remember from before, many to many, no, many to one. That's why they've written it as minus here. And I'm not sure why they've chosen minus.
I think it's because they're asking that the domain of the function f of x, right? It's less than
Oh,
3.
yeah.
So
Yeah,
the range of the inverse should be less than 3. So
there you
they're
go.
trying to
Yeah,
go
exactly.
below.
So they're gonna choose. Wait, I wish I could graph this. I would love to use Desmos just to show this off, but it's like, see, they only have 3, so you can only have less than. So yeah, do pay attention to these domain thingies. Always, when
Yeah.
it says for this, I've lost a good many marks to that on my past papers too. So okay, good to know. Next question. I'll do the first. I suppose I'll just do this question. Sure.
Oh, okay.
Functions g of x are g, f, and g are defined by this. And see, we've been given unknown here, where a is a constant. So yeah. And find an expression for the composite g and x. So remember, you put g and then you put the value of f of x, and f of x is equal to this. So you put x plus 1 over x. And you simplify that by plugging it into g. So that would be a, and then the value of x, which is this thing we just wrote here. Put that in there. This is a, by the way. Don't get confused. It's plus 1 over x. And then the plus 1. So we can simplify that out to a. Do we need to simplify this? A 1 plus x plus 1. I suppose you could multiply out the a to get ax plus a over x plus 1. As long as that working's on your page, you'll get the mark. You're good. Given that g of f of x, g of f of 2, since here we're given a specific value of x, is equal to 11, find the value of a. What that means is we've already constructed the equation. We're going to put in the values of f. For that, I'm going to use this one. We're going to put in the values of x. It's given that x is 2, so we're going to put a x is 2 plus 1 over 2 plus 1. And we're given that this expression is equal to 11. What that means is we can now find the value. Yippee. A of 2.5 is, 2.5. Don't usually, try not to use decimals, it's just easier here, but sometimes you don't want to. Subtract 1 from each side, you get 10. So a is equal to 10 over 2.5, which is 4. A is 4. We just use the g of f expression, make it equal to 11, x equals 2, and we get the answer. And now, explain why the composite function fg of x cannot be formed. Remember from before how I explained in detail why if the range of the inner function, so g, you see range of g, so the domain of g is real, so every number possible, that's real. So the range of g is infinite. There's g, infinite. And that range becomes the domain. So g's output becomes an input for f. And f can't use any inputs less than 0 or equal to 0. So f can only use inputs greater than 0, and g gives outputs all the way to infinity and minus infinity. Hell, yeah. So it goes all the way. There's no restrictions, but f has restrictions, so it can't accept g's output as its input. What you write is g's range is greater than, is outside, actually. That's a good word. Outside f's domain. And let's look at the answers here. A of, where's my mouse? A of x plus 1. Yep, we're good. A equal 4s, yes. I did cut out this question, but yeah, it's not there. I've just cut it out for time's sake. And E, we did E. The domain of f does not include the whole of the range of G. Or the domain of G does not lie in the domain of f. Sorry, range of G outside domain of f. Yes. Outside domain of f. Accept an answer that includes example. So an example would be good as well if you don't know what you're trying to word. So always try your best in each question. You might write down something that gets a mark. Okay, Vyomesh, will you be willing to help us with this question?
Sure, yeah. So looking at the question, it is asking to state the domain of f of inverse, right?
Mm-hmm.
And looking at the question, I think it's a one mark question, so it should be quite simple. So
Yes.
looking at so basically the domain of the inverse of the function is basically the range of the f of x, right?
Yes.
So looking into f of x, right? It just says that it's just looking at the graph, we
Yep.
could see that the range of f of x is anything other than 1,
Exactly.
right?
See,
Because it is
it will
having
never
an
reach 1.
asymptote. Yeah, exactly. There's an
This is
asymptote there.
so the only values of x and only values of y are here and not here. So the answer would be
The answer would be x not equal to 1.
exactly x is not equal to, use this sign, 1. Because if we look up here, just on the graph, this is the domain, right? That's the domain restriction for x is not equal to a half. Similarly, this is the range restriction. The x values are the domain, y is the range. So if you look at the y values, you'll see what Vyomesh noticed here. And that's exactly right. X does not equal to 1. There's more parts to this question. And the first one is to find an expression for the inverse of f of x. So Vyomesh,
Sure.
guide us
So
through this.
sure. So what I'm gonna do is flip the sign. So I'm gonna replace the f of x with y, and after that I'm gonna flip the signs between the x and y. So it's gonna start with x equals to
Let's see.
2y
2y
plus 1
plus 1
upon 2y minus 1.
minus 1.
Yeah. And so I'm gonna make it in terms of y. So I'm gonna multiply both sides by 2y minus 1. So that would be, yeah.
At
Then I would expand the brackets.
2xy minus x.
And then I'm going to take the 2y and put it on the left side and the minus x on the right. So by changing the signs, it'll be 2xy
Minus 1 equals 2y
2y
minus 2xy.
minus 2xy. Yeah. And then on the right hand side, I could see that I could make that in make a factor of y. So it'd be y brackets 2 minus 2x. E- yeah, and then on the left hand side, it would be minus x minus 1. Then I would take the 2 minus 2x to the left hand side. So y would be equal to,
Yeah, so we're basically dividing by this. So y would
yeah,
be equal to
minus x minus 1
minus 1,
divided by 2 minus 2x.
2 minus 2x. Epic.
Yeah. That should be right. And I mean, the mark scheme might actually be a bit different, but either way, it'll be in the mark scheme it would say OE or equivalent. So this will be
Yeah.
also considered. And now looking at question number C, it says find g of f of inverse of 3. So we've already gotten the inverse function of f, so we could put 3 inside of that and see what we get, and then put that output inside the function of g. So it'd be yeah,
Is
equals to
basically this function, but we substitute in 3 instead of x.
exactly, yeah. So it'd be minus 3 minus 1 divided by 2 minus 2 times 3, which is equal to minus 4 divided by minus 4.
Which is 1. Epic. Easy.
Yeah, that's it. Yeah.
Close
So
to 1.
that's equal to 1. And remember, that's the output of the inverse function of f with the
Yes.
input of 3. And now we put that inside the function of g of x.
Basically g1.
And so g1 equals to 1 squared plus 4, which is
So
equal
5.
to 5. Yeah.
Nice.
And for the last question, D, explain why G inverse cannot be formed. Again, it's if we look at it, right? So G of x has x squared plus 4. And when we try to find the inverse of it, it would definitely have a square root. And as said, if we have a square root in the expression, right, it's going to cause one-to-many function.
It's the whole fiasco of this is a function, this is not a function.
Yeah. Wait, wouldn't it be one-to-many function? It's not a function.
Many. Oh yeah, one to many. My bad. One to many. One
Yeah.
input, many outputs, not a function. So it would
Yeah,
not
and
be a
that's why
function.
this will be not considered as a function. And that's why the inverse cannot be formed.
Nice. Now let's check our answers. So the range of f of x, where's my mouse? Okay, there it is. Range of f of x is x does not equal to 1. The range of the inverse is the output of the range of the inverse is the domain. The domain of the inverse is the range of the normal one. Yes, it does get a bit tricky when you start thinking about it. Just the wording. And here we have our inverse function leading to this. So this is what they show. Well, this is what they show here. 1 minus x minus woo. Is that right?
We could
Yeah,
check it by
it's
inputting
just a
some
little
kind of
bit
value.
different. Yeah, there. We have this form.
Oh yeah, that works. Yeah.
So they've just like put it in a slightly different. See, or equivalent must be in terms of x. Don't allow stuff like that. As long as your fraction is, fractional, there shouldn't be any divisions. Cambridge especially, they don't like division signs or -1. They don't like x to the power -1 or x divide. They like multiplies and positive powers. Just make it over. Okay. And yep, we got 5 because we got the correct answer from previous question. And for explanation, you don't need to write an essay, guys. You just need to write many to one or not 1 to 1 or any of those. You just have to explain the in general. It's because it's just a mark. It's not your writing skills, guys. Okay. I will do this question. The function is defined as follows. Find the value of function 5. You don't have to rearrange and make a whole fancy thing. You can just do what Vyomesh showed earlier. First, find the value of f of 5, which I will put here as 5 plus 3 over 5 minus 1. Yes. Careful here, because they have given us a domain. I'm just looking at that and eyeballing it, make sure I don't forget. You might like to highlight or underline it in your test so that you don't miss over it later on. And 8 over 4 is equal to 2, so this equals 2. So f of 5 equals 2. So what does f of 2 equal, you might ask, because you've just put f of 5 into f. F of 2 equals 2 plus 3 over 2 minus 1. And this equals 5 over 1, which equals 5. So yes, indeed, f of 5 equal to 5. So yes, our answer is 5. I'll box that here. Find an expression for the inverse of f of x. This is a funny question. I selected it just because. So let's try working on this. Remember, put y as x plus 3. And then swap x and y. So you get x equals y plus 3 or y minus 1. Multiply both sides by y plus 1. Same process as previous the question in the last one. Y minus 1 equals y plus 3. Multiply xy minus x equals y plus 3. Get the y's on one side. Minus x minus 3 equals y minus xy. Get the common thingy. I'll just move that over there because I don't have space. Y equals 1 minus x equal to minus x minus 3. And if you do this, you get y equals to minus x minus 3 over 1 minus x, which, if you write equivalently, if you just multiply top and bottom by minus 1, multiply top and bottom by minus 1, keeps the value constant, which you get x plus 3 over x minus 1. And what do you look at that? F minus 1 of x is the same as f of x. So it's actually a self-inverse function. And that's why when you do it twice to 5, you go back to 5. You go to 5 to 2, then you go back to 5. Self-inverse. Yay. And if you look at that, here's y. Here's what you get marks for. Do pay attention to what you get marks for, guys. It's worth going through the mark scheme once, or twice, just looking at what all of the notations mean and what type of writings will get you marks. It's good to know what you're doing. Okay, this is a fun question. I don't know how Vyomesh, you can help us with this, but can you remind us about what does an inverse function do when we do it? Look at it on the graph.
Sure. So whenever we inverse the function, right, it is always reflected by the line y equals to x. So to draw and sketch it, what we would do is first of all draw a dotted line like how Pratyush has drawn, and then just make a reflection of it.
You can see here. Just go here. This y.
So it would kind of like an infinity sign.
Yes. You'd go like that.
Yeah.
Nice. And that's all. That's all you have to do, guys. 1 mark, drawing. You get to practice your artistic skills. Amazing. Okay, now we're on to the next half of this, which is going to be transformations. There are 3 transformations that we cover at AS level. There are translations, which means moving stuff around. Well, that's not a good error. Moving stuff around. Stretches, which is like getting wide. I don't know. And reflections, which is what we just looked at earlier. If we have like circle and reflect along this line, circle, same distance. And each we learn how to apply separately in the x and y direction. And operations outside the brackets of f of x, e.g. this 3f of x plus 2, will actually affect its y values. And they're applied after the function brackets are opened. The functions brackets, you can treat them as a bracket in your order of operations. And operations inside the brackets, such as this 3f of x, 3x plus 2, they're applied before it's opened, and it affects the y value. Did I just say y? It affects the x values. Oh, I thought I had another slide here. Anyway, when you're opening these, we'll work on how to open them. So let's have f of x is equal to 3x plus 1. Just for example, if I'm going to apply this, what it's going to look like is 3, and you put f of x, you substitute f of x for f of x itself. 3x plus 1 plus 2. This is what this becomes. And you simplify that out to get 9x plus 3 plus 9x plus 5. So this is f of x after the transformations, and it becomes a new curve or line in this sense. So let's that wasn't very clear, but we'll look at them one by one. So let's look at translations first. Translations is when you add or subtract stuff. It's straightforward. When you add stuff inside the brackets, it moves it horizontally. Do note that whenever you do something to x, it actually does it backwards. And that's because if you look at this one. Here's the curve f of x. We add 3 inside the brackets. We're effectively moving it minus 3 units that side. You can look at this on a graph. You can try graphing it out. I think most textbooks have graphing questions on these where you have to draw stuff, and that really helps you understand. But in this case, it's just enough to know that if you add a inside the bracket, it moves it minus direction, so to the left. And if you do f x minus a, it moves a horizontally, plus a horizontally. So that's to the right. Remember your directions, guys. Plus, minus, plus, minus. And now let's look at vertical translations. Here we have f of x3. And for wide translations, outside the brackets, you don't need to worry. They're exactly as they are. If you add a, it moves it up by plus a. So you add 3, moves it up by 3. Subtract 3, it'll move it down by 3. Same story. And yeah. Stretches are similar. They're actually very similar to translations, but they're multiplication instead of addition and subtraction. Multiplication and division. So if you look here, we have a curve f of x. We multiply it outside, multiply the y by 3. It's going to turn the y 3 times taller. And if you do, that's outside the brackets, that scales it taller. So if you're like this, it'll get it taller if on the same scale. Compared to if you have f of x, f of ax multiplying inside the brackets. If you have like a curve like this, and you multiply it by 2, it's gonna make it thinner. It's gonna stretch by factor 1 over 2. It's gonna half it. If you want to make it wider, then you actually have to multiply it by like a third. That's gonna make it 3 times wider. This is just a general idea of the stretch. We're going to look at questions in a moment. Hold on. And one last thing, reflections. These don't really matter about whether they do opposite or not. It's actually pretty easy to get them confused, so pay attention here. F of x, and you negative it. It's a reflection in the x-axis. It's a reflection using the x-axis as a mirror. It's not a reflection that changes x values. What that means is, you see here, reflection using this line, f of x, this line, the x-axis, as a mirror. And when you use it as a mirror, it goes like, you see, we've just mirrored it. What's happening here, these y values, you see, these y values are becoming negative. This y, this negative y. And that's what it'll happen. And if you do that inside the brackets to x, that's a reflection on the y-axis, this y-axis mirror. Reflection. It's not a mirror though, because a mirror would produce two images. But what's happened here is, you see the original curve looked like that. This is the x value. Now this x value is negative x, but has the same y value. So effectively, it's just flipped along the, it's reflected along the vertical axis. Whereas this one, it's reflected along the horizontal axis. Sometimes it gets confusing when you say x and y, so I like to say horizontal and vertical. And this is the single most important thing in this topic, the order that the transformations happen in. You can combine transformations, you can do one after the other, however you like, but you have to make sure that the order you describe them in is consistent. Look here at minus f of 2x, minus f of 2x plus 3. There's three things going on here. First, we do a horizontal stretch by the factor a half, remember? Because inside the brackets, things go sort of backwards. It's multiplying, so it's scaling, and it's 1 over 2, so it's half. Reflection along the x-axis, because that's outside the brackets, you see? Outside, it's affecting f of x, not x. So what that looks like is, it's basically flipped upside down, from up top to bottom, let's say. And finally, a vertical translation of 3 units up. What this looks like is here. I have this curve f of x, and I have this curve minus f 2x plus 3. As you can see, the horizontal stuff, the scaling by half in this x direction, scaling, doesn't really affect the order, because it's the only thing happening to x here. Since it's the only thing happening to x here, the order of the x transformations don't matter. But the order of the y transformations, you'll see there's two things happening to y. One, there's a reflection, and two, there's the translation by plus 3. And the order does matter here, because first we flip it and then we add 3. But what would happen if we added 3 and flipped it and then flipped it? It'd look like this. First, because it's in the brackets, we first add 3 and then we use this minus to flip it. And that looks like this. Because what happened is we first moved this up by 3 and then we flipped it, which moved it further down. Whereas here, we basically flipped it and then moved it up 3. It's quite a difference. So what order do you do these things in? Well, you just use the order of operations. They're very simple. First, you do everything inside the brackets, the horizontal stuff. So f, let's say 3x plus 2. Of course, you scale first, and then you add, and then you transform, and then you translate. But if it was like f 3x plus 2, what's going on here? First, you translate, and then you scale. Same thing outside the brackets. If you have f 2x plus 4, you see you first scale and then you add up and down. And same if you have brackets around it, then it changes it. You get the idea. So let's just do a practice question about this. Write a thing to transform f of x onto the curve g of x using these three thingies in the order given. Let's say 1, 2, 3. And find an expression for g of x. So first we're going to write it as f of something, right? How we're going to do this? First it says a vertical stretch of a factor a half. Let's think about this. A vertical stretch of a factor of half. A vertical stretch, that means it's multiplying f. And outside the brackets, the operations are the same. So half of f, half times f of x. Yes, this does our first operation. And we want a reflection in the y-axis. What's that? It's the y-axis. So if we have like a curve like this, it's going to look like this. How do we do that? It's minus x. So yep, second thing done. And then a translation of 2 units to the right. So remember, you multiply by minus 1 first. So what you're doing is this minus 1x, treat that as minus. And after you multiply, then you add a translation of 2 units to the right. Remember, it's to the right though. And since inside the brackets things work differently, it's subtract 2, which actually makes it plus 2 in the right direction, right? So this is what our thing looks like, half f minus x minus 2. And now we need to put that into f of x and get our expression. So it looks like half, and write f of x, this, but treat x as this. Treat x as the thing inside the bracket. So half of 2, half times 2, what's x? X is minus x minus 2, minus 18. Simplify that. It's minus x, because this becomes 1, and minus x minus 20. This is our new curve with these 3 applied. And the popular question that all examiners love to ask, they don't usually ask you to make transformations one by one. They give you a curve, they give you another curve, and they ask you what transformations map the first curve onto the second curve. So let's do some questions. Vyumesh, you ready?
Yes, sir. Okay. So question number 6. Functions f and g both are defined for x which belongs to real numbers and are given by the following. But first expressing each of f of x and g of x in a complete square form, express g of x in the form of that form where p and q are constants. So to do that, it says by first expressing f of x and g of x in completed square form, right? So as learned before, let's do f of x first. So I would do x minus 1 square. And then minus 1 square plus 5. And then I would simplify that into x minus 1 square plus 4.
Plus 4.
So that's f of x. And g of x, on the other hand, would be x plus 2 square, because we're dividing the coefficient b by 2 square, minus 2 square, and then plus 13. Now simplifying that would give us x plus 2 square plus 9. And now it says express g of x in the form of this. Oh, okay. So let's see. F of x. Okay.
Yes.
Okay, that makes sense now. Yeah. So basically, if we look at f of x, right, in the x area, right, in the brackets under the square, if we substitute the x with x plus 3, right? The brackets would be the same. So first of all, we're doing f of x plus 3.
F of x plus 3.
Plus 3. Because now if we consider this, right, and if we put x plus 3 in place of the function of f,
Putting
right?
plus 3 here.
Yeah, and then that will basically give us x plus 2, which is the function of g, right? And then after that, we can see that f of x has plus 4 outside, but we need a plus 9. So to do that, we would add 5 here.
And this is outside the brackets.
Yeah, exactly. So that will be g of x in terms of the form following for the function of f. Yeah.
Yep. So these three are our answers. So now describe the transformation which transforms f of x onto g of x. We've already done this, so it's pretty straightforward now.
Yeah. So looking at this, right? Inside of the brackets of f of x, it's x plus 3. So that basically tells us that it's first of all shifted to the left by 3 units, and yeah, and then after that, there's a plus 5 out of the brackets that shows us that it's gone up by 5 units on the y-axis. So either we could write it like this, or we could also write this in a vector form.
You could write minus
That-
3 plus 5.
Yeah, like that.
That's
So that's
a transformation. Epic. That's all there is to this question. You two completed square forms, and then the transformation between the two, and then put that in words. Translation or shift, or this and this. Nice.
Also,
Okay.
another thing, can you go back to the previous question? One thing is that here they're actually asking 1 mark for translation or shift, and
The word
go
itself.
back one slide.
Mhm.
It's asking for the transformation, right? So transformation could be anything. It could be stretching. So we have to also specify that we're doing a translation, because that's a form of
Yeah.
transformation. Otherwise, we would have lost 1 mark right there.
Yeah.
If it is a stretching, we do stretch. If it is a translation, then we specify what it is exactly.
Describe. Also, the keyword describe will give you the hint that you need to use some words as well. Okay, good point, Vyomesh. Okay, how much do we have? Yeah, this function g of f. I think I'll do this one real quick. They're all pretty low marks. You can help us at the last question, Vyomesh.
Sure.
Again, it's the same idea. They love using these things because once you have the thing in square form, you're basically just moving around its vertex. See, moving around the vertex is easy rather than moving the curve. So they always like you to put the curves in completed square form. Okay, so let's do that. F of x, coefficient here is minus 4, so we're going to put minus 2. Square the thing, subtract minus 2 square. Add 9, simplify it out. Minus 2 square, 4, 5, 5. And do the same thing. Oh, slightly different here. They want you to do the whole multiplication. Multiply the whole thing. So express g in the form this. What that means is, take g, you take the divide everything by 2 and put it outside in brackets. X squared plus 2x plus 6. No, square brackets because I'm using square brackets. And then you complete square inside 2x minus 1 whole square minus 1 whole square plus 6. And that looks like 2x minus 1 whole square minus 1 plus 6 plus 5. There you go. And now we express g of x in the form k f of x, where k is introduced. So we're using f of x and adding / multiplying. So we're transforming f of x onto g of x. What does that look like? Well, we already know that this 2 outside, this 2 is outside. So we can do 2f, because that'll multiply this. So what maps this expression onto this expression? If, as you can see, there's a 2 multiplication of the whole thing. That's what k is. And what's h, you might ask? What? Well, we have to turn this x plus 2 into x minus 2 into x minus 1. So we just add on a little 1 here. So x, add on a little 1 inside the x area. And that gives us x minus 1. So that's our integer. We've turned this into this. This is our form. So Vyomesh, can you tell us what transformations we just did and in what order?
Sure. So first of all, we are shifting it to the left by 1 unit. And then after that, we're scaling it on the y-axis by 2.
To the left, so that's minus 1 unit. Left.
Yeah.
Whoop. Left. And scale in the y-axis.
Yeah. By a factor of 2.
Factor 2. So each of these things gets a mark. Translation 1 mark, and the units 1 mark in the x-axis. Axis mark, my bad. And scale 1 mark, x-axis factor 2 mark. Let's look at the mark scheme. Yep, these are the forms that we did. And this is the form. Wait a second.
I think there is a slight issue with the translation.
Ah, yes, I have missed the sign. As you guys see here, this is plus 4. And hence this is a plus 2 here. Why did it become minus? This should be a plus 1.
That explains it.
Yeah. So this should have been an addition of 3, which means this should have been an addition of 3, which means the translation is indeed of 3 units. Nice.
And that explains the mark scheme. So it'll be minus 3 units to the left and stretch by a factor of 2 in the y direction.
Yes. Okay. Nice. I think this is nope, not yet. This is one of the last questions. Whoa, almost dropped my pen. Express this in the form completed square, where a and b are constants, one-to-one function, blah, blah, blah. Oh, fun thing. This notation is also used for functions. Get used to it, guys. It's just f of x with a funny arrow. Means same thing, f of x. And for y equals k, results translating the graph. Express g of x in the form this.
Should we try this question then?
Oh, these.
Sure.
Wait. Is this the same question? Oh yeah. I know what this is here. Okay, yeah. You can try it, Gamesh.
Sure. So first of all, it's asking us to express it in the form of completed square. So what I would first do is take -3 as a factor of the -3x squared plus 12x. So that will be x squared plus minus 4x. Brackets close, and then plus 2. After that, we could turn the inside of the brackets into, let's just do -3 times x minus 2 square. Minus 2 square. And then brackets close, plus 2. And now when we expand that, we would get -3 brackets x minus 2 square. So that's -4 times -3 plus 2. So that would be 14.
Nice.
Let's just check that again. I think that's correct. Yeah. And then it's asking the one-to-one function, and that's like just the part A, right? And
Mhm.
in question number E, it's asking us express g of x in the form of this as a, it's basically a quadratic, right? So it's asking that let's see, the one-to-one function f is divided by this. So that's basically the function that we converted into completed the square form. The result of the translation of the graph by y equals to fx by negative 3 units to the left and 1 unit to up, it basically gives us g of x, right? So looking at the completed square form, to shift it by 3 units to the left, we would be adding 3. So x would be replaced by x plus 3.
So, so basically, f
X plus
x
3, yeah.
plus 3, and then
Yeah.
plus 1
Plus
just for that
1.
one.
Yeah, because then we're also shifting it by 1 unit up on the y-axis. And
Mhm.
now when we put this inside the function that we have already given, right?
So minus
So
2 plus 3
yeah, so
plus
that'd
1
be plus 1 square, and then plus 15.
plus 15.
And then again, it's asking us in a quadratic form, right?
Yeah.
So we would just basically expand this. So it'd be negative 3 times x squared plus 2x plus 1. Brackets close, plus 15. Expand that. So minus 3x squared minus 6x minus 3 plus 15. That's
No,
basically,
minus 3 plus 15.
yeah. So that would give minus 3x squared minus 6x plus 12.
And that is in this form, our
Let's
constants.
just check. I think that is
Yes.
correct. Yeah.
Plus 12. Yep, we good. And yeah, this is the last question for real this time.
Yeah.
The graph of y equals fx is transformed to the graph blah blah blah. Describe fully the two single transformations that have been combined to give the resulting transformation. This is pretty straightforward. They've done all of that work of completing the square and testing how much they move for us. So we just need to interpret this. So f of 2x minus 3. The multiplication means scale, and it's inside the brackets, so it's sort of like backwards. So it's a scale of huh, scale of half of factor half in x direction, and the second one is a translation or shift translation by by minus 3 units y direction. To be more sure, you could just write it as a vector 0 minus 3 or 3 units down, but the mark scheme will accept that regardless. I don't have the mark scheme for this one pulled up. Okay, so those are the two transformations, and the order doesn't matter because they're separate x and y. If you have multiple things going on in x and multiple things going on in y, then the order matters. But if you have just one of each, no problem. It doesn't ask for the order. Okay, and that brings us to the end of this presentation.
Great. Yeah. Thank you all for tuning in, and we hope you had a great understanding of the topic. And you could get hold of the notes on the ZNotes website. Our socials, our media handles are on display. So connect with us. Feel free to drop in any kind of questions that you might have. And yeah, see you in the next upload. Thank you, everyone.